Hello, my name is Melanie Florez, and today I will be presenting the topic of amygdala activity and social cognition, specifically in understanding overactivity and activity and their impact on behavior. So, the amygdala is a small, almond-shaped group of nuclei located deep in the medial temporal lobes. It plays a central role in processing emotions, especially fear, threat detection, and emotional memory. So, while it supports survival by reacting quickly to danger, it also helps us interpret the emotional significance of social cues. Different amygdala nuclei have specialized roles. The lateral nucleus receives sensory input. The basal nucleus helps form emotional associations. And the central nucleus sends outputs that activate psychological and behavioral responses. This division of labor allows the amygdala to efficiently trigger and store emotional reactions. Now we're going to talk about the brain's social circuitry. So, starting off, social cognition involves a network of brain regions that helps us interpret other people's emotions, intentions, and behaviors. The amygdala is key in this network because it quickly identifies emotionally charged social signals. It works alongside the prefrontal cortex, anterior cingulate cortex, and the temporal parietal junction to guide social behavior. Moving on, emotional stimuli travels through two main routes. We're going to start off with the fast path, which sends raw sensory information from the thalamus directly to the amygdala. This enables a quick instinctive reaction. On the other hand, we have the slow path, which sends the same information but this time through the cortex, where it's interpreted in context before reaching the amygdala. This dual system allows both immediate and reflective responses. So, in a healthy brain, the amygdala helps detect actual danger and modulate emotional memory. It is regulated by the prefrontal cortex, which helps tone down excessive reactions, and the hippocampus, which adds context. This balance is very important as it helps us respond to fear without overreacting and interpret emotions in social settings appropriately. However, when the amygdala malfunctions, emotional regulation becomes unbalanced. Overactivity leads to anxiety and chronic stress, while inactivity causes emotional blunting, apathy, and risky behavior. These dysfunctions can result from trauma, brain injury, or neurochemical imbalances, and disrupt the brain's ability to interpret and react to emotional and social cues. Symptoms vary based on the type of dysregulation. So, for example, overactive amygdala might cause hypervigilance, social withdrawal, irrational feels, and panic attacks, while inactive amygdala might result in lack of fear, poor social awareness, impulsivity, or flat affect. These symptoms are visible in real life behavior and often indicate deeper neurological conditions. The amygdala's dysfunction also plays a central role in multiple psychiatric disorders, and each condition reflects different patterns and how its circuits break down. In post-traumatic stress disorder, or PTSD, the amygdala remains highly active even after the threat is gone. It fails to be properly regulated, leading to constant hypervigilance and emotional flashbacks. In panic disorder, small sensory inputs are interpreted as catastrophic. In social anxiety disorder, the amygdala responds strongly to facial expressions of judgment, especially anger or contempt. Lastly, in Kluver-Bucy syndrome, bilateral damage to the amygdala, often from trauma, stroke, or infection, leads to fearlessness, hypersexuality, and the inability to recognize emotional significance, showing the importance of the amygdala in social boundaries and safety. Each of these disorders arises from disruptions in specific amygdala subregions and their connections with the prefrontal cortex, hippocampus, and hypothalamus. Overactivity is often triggered by chronic stress, trauma, or early life adversity. On a cellular level, low GABA and high glutamate make the amygdala more excitable. Prolonged stress can also sensitize the amygdala, lowering the threshold for threat detection and leading to disorders like social anxiety or PTSD. Inactivity might stem from bilateral brain injury, degenerative diseases, or chronic drug use. Some medications and substances might suppress amygdala activity. This leads to emotional detachment, inappropriate social behavior, and the inability to recognize threats. So here we can see a summary contrasting overactive and inactive amygdala functions. These two are extremes on a spectrum of emotional regulation which we have been talking about. In overactivity, people experience excessive fear, even in safe situations. The world feels threatening, and social engagement becomes overwhelming. This leads to avoidance, withdrawal, and intense psychological distress. In inactivity, people might experience the opposite problem. They don't feel enough fear. They might misjudge danger, act impulsively, or show disinterest in other people's emotions. This is often seen in psychopathy, brain injury, or certain neurological syndromes. Importantly, both dysfunctions impair the person's ability to adapt to social environments, form healthy relationships, and manage internal emotional states. So, in healthy brains, the amygdala operates like a smoke detector, alerting us when there's real danger, but staying quiet when there's none. This regulation means the alarm either never shuts off or never goes off at all. Restoring the balance between activation and inhibition, between emotional salience and control, is key to mental health. So, while medications can help manage symptoms of amygdala dysregulation, non-pharmacological approaches offer powerful long-term strategies, especially for strengthening cognitive control and emotional awareness. Cognitive behavioral therapy is one of the most effective treatments for anxiety. It helps reframe fearful thoughts and teaches the brain to reinterpret stimuli as non-threatening. Mindfulness and meditation train individuals to observe their thoughts and emotions without judgment, activating the prefrontal cortex and reducing amygdala activation. Exposure therapy gradually desensitizes the brain to fear stimuli by safely reintroducing them in controlled environments, retraining the amygdala to recognize when danger is no longer present. Lastly, with heart rate variability biofeedback, they use breathing and monitoring to enhance vagal tone and parasympathetic activity, calming the emotional brain and improving emotional regulation. Together, these techniques improve the brain's top-down regulation, empowering people to build resilience, reduce reactivity, and re-engage in meaningful social interactions. These are my references used. Thank you so much for watching.